Hey all, today we're going to talk more about similar triangles and proportions, and we're going to talk about proportions that exist in one triangle. So there's a few relationships we're going to talk about. The first one here is the Sidesplitter Theorem. And so we have a triangle, and then this segment that goes through the triangle, and if you remember, these two arrows mean that those two sides are parallel. So if we have this scenario where a segment intersects two sides of the triangle, so it intersects this side and this side, and then it's parallel to the third side, then we get proportional relationships that exist. And there's a bunch of different proportions that we could write, and the one that I see as being the easiest would be if I were to extend this parallel line. I sort of create fraction bars between two of these pieces, and what I get is A divided by B and C divided by D. Oops, that's not good. And those two ratios will be equal. So again, I had A and B, C and D, and these two were sort of on the same side of this pink or purple line that I made, and so they would both be on top of the fraction, and then B and D would be on the bottom. And there's a bunch of other ways that we could write this, but you just got to get comfortable writing it the way that you're comfortable with. And we have these pieces that correspond. So let's look here. We have this piece that's above this parallel line, and then that same piece that it corresponds to is right here. That should be 32 minus 12, which is 20. And so I have these fractions formed, my question mark over 21 and 20 over 12. And now I just have a proportion to solve to figure out how long that missing piece is, which is 35. I have a very similar situation. This is a corollary or something that is built off of an original theorem. So this is similar to the side-splitter theorem because we don't necessarily have a triangle. What we do have is this line that intersects two transversals that's parallel to these other two lines. And the relationships formed will be very similar to what we just had. So I actually, this line is already extended, so I sort of have these natural fractions, A over B and C over D. And that can help us solve. In this problem, you notice we don't have this little piece. We don't know how long it is, and figuring out how long it is could be messy. We could write that this is 18 minus question mark. That might get a little messy for us. So what we can do is just make sure that the parts that correspond from each side of the picture are in the same place in the fraction. So I'm going to find this piece to be 4, 9 minus 5. And then I'm going to say that this whole length that's 9 divided by this length that's below this middle parallel line, 4, is equal to the whole length over here, 18, divided by this little piece that's below the middle parallel line, question mark. So the pieces that I'm using correspond. Whole length, those are both on top. Piece below the parallel line in the middle, piece below the parallel line in the middle, those are both on the bottom. So as you can see, there's plenty of ways to write these proportions. And then we're just solving a proportion like we have already this unit. So pretty much the new part to this is that we have to be able to set up a proportion from the picture. Here we have an angle bisector. We know that this is an angle bisector because it is making two congruent smaller angles. Again, if I extend that angle bisector, what it looks like is that I have two fractions that are written. I have a over b, and I have c over d. Very similar to the other ones. And again, there are other ways to write these fractions, but I'm going to try and be consistent to what I just showed. If I extend my angle bisector, I have 10 over question mark, and I have 8 over 4. Again, the 10 and the 8 come from the same side of this green line, and the question mark and 4 come from the same side. Just have to make sure things are matching up, and that comes with practice. And then we can just solve the proportion, which I'm hoping is the easiest part of this type of problem. So here I have my side-splitter theorem, and I'm going to extend that parallel line that goes through the middle. And this might be a little hard to see, but this question mark is supposed to be telling you how long this whole side is, and 24 is supposed to be telling you how long this whole side is. So we don't know these little pieces below that parallel line through the middle, but we can relate the whole side to the piece above the line, and the whole side and the piece above the line. So question mark over 25, 24 over 20, and we solve the proportion. In class, I'll show maybe some other ways that you could write these two proportions, and still it will lead you to the correct answer for how long this side of the triangle is. This is the corollary. So 3 parallel lines, 2 transversals. We have the whole distance between these outer parallel lines, and then the distance between the middle and the bottom one. And so we're going to find this distance here by doing 32 minus 12, which is 20. And so we're going to relate the large distance to the bottom, large to the bottom, and then we can solve again. Hopefully that proportion solving is the straightforward piece. I'm going to do one last one with you, and then I'll let you do a couple on your own. Here's the angle bisector. I know it's an angle bisector without being told, because this segment makes 2 congruent smaller angles in this triangle. And so I have these fractions written, 9 and 24, 15 and question mark. And again, we're cross multiplying and solving the proportion. So I want you to give these two a shot. I want you to pause, try both of them, then press play, and I'll reveal the answers. I'm not going to go through the answers, but I'll show you the work that I did. And if you have questions about them, we'll absolutely discuss that when we meet together in class. So again, if you didn't get the same answer as me, make sure you ask me a question in class. If you got the same answer as me, but your proportions looked a little different, that's okay. Like I said, there's a few ways you can write these proportions. Just be consistent.